Good evening, students. My name is Rahul Sinha. Now I am going to discuss about electromagnetic wave and transmission line. So basically, electromagnetic waves is a combination of electric wave and magnetic wave. So before discussing electromagnetic wave, I want to introduce some basic definitions like dot product and cross product, for example. Dot product is basically nothing but a scalar product. The scalar product is only give the scalar of the field A and B, two vector A and B. So consider here. So here we can see that this A and B is connected with angle theta AB. So here dot product means A dot B equals to modulus A and modulus B cos theta AB. So here generally at x direction unit vector will be I cap, and in y direction j cap, and z direction k cap. So here suppose A is x, B is y, and across perpendicular direction is z axis. So we can see that suppose I cap dot j cap equals to mod I cap j cap cos the angle between I cap j cap here is 90. Cos 90 nothing but a 0. That's why I dot j cap equals to 0. Similarly, j cap dot k cap equals to 0. K cap dot I cap equals to 0. So this is the thing. And if we take same unit vector like I cap dot I cap equals to cos the now angle is between I cap and I cap, that is 0, and cos 0 equals to 1. Always remember the magnitude of the unit vector is always 1. So similarly j dot j equals to 1, k dot k equals to 1. So now next is cross product. Cross products, it gives the magnitude as well as the direction of the resultant vector. Say I cross j equals to angle between I cross j means 90 degree. That is cos sin 90 equals to 1. So I cross j equals to 1. J cross k equals to 1 cross I equals to 1. So if we take different unit vector, cross product is 1 with angle between these two vectors should be 90 degree. An interesting property is I cross j equals to minus j cross I, and this is the relation between if we write oppositely. Similarly, j cross k equals to minus k cross j. The basic thing. So here in this formula in cross product, class an is the unit vector, the resultant unit vector which indicates the direction of the resultant vector across b direction perpendicular of the a vector and b vector. So next is del operator. Del operator nothing but the vector differential operator. So the symbol of del operator is like this. Del opposite this. And for Cartesian coordinates and circular cylindrical coordinates and spherical coordinates, So different del operator for different coordinates I have given here expressions. Now next. Okay, gradient of the scalar. Gradient means what? That is gradient suppose V equals to del V. So here V is the scalar and resultant this gradient V will be the vector. Basically this vector represents the both magnitude and directions with the maximum space rate of change of maximum space rate of increasing V. So suppose consider time. Time will not change here. So not time, temperature will not change here with time. So that temperature in each and every room, the coordinates, suppose I am given coordinates x, y, z here. So x, y, z basically variables. So each and every room that coordinates, suppose x is 1, 1, 0. So each and every room is points, so we can indicate the temperature. So here gradient of temperature, that means the direction where at that point the temperature directing the where the temperature is increasing, in which direction temperature is increasing, and magnitude means how fast the temperature is increasing in the room in that particular point. So that is the gradient. So next is the divergence. Divergence is nothing but the outward flux per unit volume at P. Divergence at P means outward flux per unit volume at P, which shrinks at P. Suppose positive and negative charge. So positive charge field comes out, electric field comes out from the positive charge and enter in the negative charge. So the positive charge, we can say that at this point, positive point charge I am talking about, at this point positive charge, it is divergence is positive, and this negative charge at this point, the divergence will be the negative. Also we can say that this is the source, the positive charge is the source and negative is the sink. So for better understanding, I am going to explain, this is the water tap. Suppose this is the bathtub, and where water is come outside from bathtub, this is the directions and this is the direction water is coming. So at this point, we can say that the divergence at this point is positive and at this point is negative. It is a source and it is a sink. What is the remaining parts? What is first flow in that directions, go directions like that, it will come outside. So in that area, divergence will be zero, like electric field. So field, like this electric field in here. So in that point, if place this point P here, that divergence at point P will be zero. And next I am going to explain the curl of a vector. So curl of a vector is denoted del cross vector A. So which is explained the rotational field. Rotational field, its circulation will be maximum at of a vector A per unit area. That area will be enclosed by the path L. Okay, here the del cross A, we can write this one, del cross A equals to magnitude this x, y, z. X, y, z means the unit vectors which is directionally directed in x, y, z axis respectively. And this is the del operator, del x, del y, del z, like that we have written here. And x the coefficients of the vector in x direction, y direction, z direction respectively. So basically, curls of any vector is indicating the rotational field only. So for example, current is flowing in conducting wire, say I. So around the rotation magnetic field is generated. That is rotational field. So in case of, we can say that magnetic field, there is no source or there is no sink. Okay. Next is the Laplacian of a scalar. So Laplacian's operation may be in scalar or vector field. Suppose for scalar, del square goes to A. For scalar, we will write del dot del A. If A is the scalar field, so vector, this Laplacian operator will express in that way. Del dot del A. That means this is the gradient, divergence of the gradient of A. So for harmonic field, basically this is the derivative with respect to space. That means x, y, z. In case of harmonic field basically changing with time only. So del square A equals to 0. So here I have given the V. V is the voltage here. Voltage is the scalar quantity. So if in case of scalar quantity, in case of vector field like del square, any vector like B, suppose del square B is a vector, what we will write, the expression will be del dot B minus del cross B. This is the expressions. So both we can calculate by using this Laplacian operator. So next I am going to explain solenoid field and conservative field. So solenoid field basically when the field, if we take the solenoid field here, divergence. So a field is said to be a solenoid if the divergence is 0. This is called solenoid field. For example, magnetic field. If we take magnetic field divergence, that is 0. And next is conservative field. Conservative field, in case of conservative field, a field is said to be conservative if the curl of that field will be 0. For example, electric field. If we take curl here of this electric field, that is 0. Electric field is not a rotational field. Next is electrostatic field. So basically I am entering to the main unit 1. So basically electrostatic field, from this word only we can say the electrostatic, that is electrostatic, that means the charge will be the static. Charge will not run. Static charge, we will discuss the field from the static charge only. Charge may be positive, may be negative. First of all, electric field intensity and electric flux density. What is electric field intensity? Suppose one point charge, say P, placed at point P. Suppose this is the electric field. Within electric field, any directions, electric field, it doesn't matter. If point charge placed in that electric field, and what will happen? It will experience some force. That is called electric field intensity. So electric field intensity E equals to F by Q. So Q here, the charge of that charge is placed in the electric field. So force is basically experienced on that point charge. So and we know that from the Coulomb's law, F equals to Q1 Q2 4 pi epsilon naught R square AR. So basically it comes from Coulomb's law. And E equals to F by Q. So here, if we consider Q1 equals to Q2 equals to Q, it's the same charge. So after that, Q equals to 4 pi epsilon naught R square AR. Basically, AR is the unit vector, gives the direction in which direction the field is going on. So this is the expression, electric field intensity. So next is electric flux density. So what is flux? Flux may be electric and magnetic. In case of flux electric, we denote by this. And in case of flux magnetic, we denote it by this. This is